Yeah, hi everyone. Mr. Market here. In today's video, I'm going to show you how to calculate compound interest again. But today, the one example I'm going to go through is when the interest is compounded more frequently than annually, so more times than just once per year. The previous video, I showed you how to work out compound interest when it was being compounded annually. And you can see that the formula there is slightly different from the one I'm using today. The only difference though for today is I'm introducing this value of K. And K is basically the number of times that the interest is compounded per year. So for example, if it's compounded monthly, the value of K will be 12. If it's compounded quarterly, the value of K will be 4. If it's compounded half yearly, the value of K will be 2. In the previous video where it was compounded annually, the value of K was simply just 1, and we left it out. Anyway, let's get into this example and start today's video. $8,800 is placed in an account which pays 4.8% per annum interest compounded monthly. Find the account balance after 3 years. So again, we're going to work out the account balance, which is the final or future value. We do know the present value, which is $8,800. The interest rate per annum is 4.8%. Now, what we're actually going to do with that 4.8%, which is per annum, per year, is to break it down into an interest rate per month, because in this example, it's compounded monthly. So basically, my value of K is 12. So I'm dividing here by 12. So 4.8% divided by 12. Okay, so if you need to get your calculator out and do 4.8 divided by 12, 0.4. Now that's 0.4% per month, basically. I've just calculated an interest rate per month. But although that looks like a decimal, it's still an interest rate per month. I need to convert it to a decimal by dividing by 100. So final step is to divide by 100, which would then take it to 0.004. And then I can just pop that value straight into the formula here for I over K. Now, to the power of K times N, that's, again, the number of periods that my interest will be compounded over 3 years. So N is equal to 3 years, but I'm actually going to multiply that by 12 because it's compounded monthly. If you had an example, which is 36, sorry. If you had an example where you were compounded quarterly, then your value of K would be 4. So you would be dividing your rate, your yearly rate by 4, and you'd be multiplying the number of years by 4 to work out how many times that interest would be compounded. If it was half yearly, then your value would be 2, okay? Anyway, now that we have those values, it is simply a matter of inputting them into the formula to work out that future value. So future value is equal to, in this case, the present value or the initial principal that was invested of 8,800 times by 1 plus my new interest rate per month, which is 0.004 to the power of the number of periods, which in this case is 36, 3 years times by 12. Again, just put that straight into your calculator. So 8,800 times by 1 plus 0.004, all to the power of 36. So 10160, so it should be $10,160. And because we're talking about money, we'll round to the nearest cent, so 6 cents. 10,000, so the future value, sorry, will be $10,160.06. Let me just make sure that was right. Yep. So there you have it, guys. It's slightly different from the formula I showed you when I introduced compound interest. In that formula. I left out K because K was the value of 1. But make sure that when it's compounded more frequently than once a year, so in this case, whether it's monthly, divide the rate by 12 and multiply the number of years by 12. But if it's quarterly or half yearly, your values will be 4 and 2 respectively, okay? Because compound interest is commonly compounded at those time intervals. Anyway, thanks for watching and hope that helps.